Now here we're going to get started working with dependent samples t-tests. These are two samples that we believe have some connection together in some meaningful way, and thus this is going to shape the way that we're going to analyze. So, looking back at previously at our types of samples, we were looking at independent being two samples that are not connected to any way, and then we were looking at dependent matched pairs, which is where we're working now. And here we're going to be using sample values that are matched together in some manner. So we talked previously about some examples of this being two measures that come from the same participant, like a before and after. Two measures that are matched together in some meaningful way, like a parent-child connection, or perhaps if we were looking at two spouses connecting them together, or also when we want to control for some particular variables. So we've matched some people up on particular characteristics due to the questions we're trying to answer. Now, do not automatically use the dependent or matched pairs whenever you have paired data. You need to think carefully about whether there's a reason to be matching the data together or not. So let's take a look at kind of a research design and thinking about accuracy and how independent and dependent samples pairs might shape this differently. So, which approach do you think would provide a more accurate understanding of the effectiveness of an intervention program? Option A, where we have 100 students that take the SAT test before a training program and again after the training program. Or B, 100 students who have completed the training program take the SAT, while a separate 100 students without the training program also take the SAT. So which one is going to show you the likelihood of the intervention program in producing a change in an individual's performance? Option A is going to be the best option. It reduces the extraneous variables of just individual differences between people, and it also lets me see specifically how a student changed on their intervention program. So I have their before score, and then the intervention program, they have their after score, and I can calculate a difference value, what we would call a D, a lowercase d, to see how much did that training program change that individual's score. So that increases my understanding of how an intervention program is going to affect individuals specifically and uniquely. So let's also take a look at this in terms of doing interpretations. So here, let's look at this problem. We have a comparison of city highway fuel consumption ratings done in miles to the gallon for 5 cars. And they're measured under an old rating system, and then B, we also have them under a new rating system. And we're going to use a 95% confidence interval to assess whether changing the system resulted in different ratings. And I'm kind of pulling this from problem number 2, the data they have there on page 467, but we're going to do something a little different with it. So using this, we're going to make a 95% confidence interval for using both approach for independent samples and for dependent samples, or the matched pair. And here are the two different confidence intervals that we get. So for our independent samples, we have negative 7.18 milligrams to the gallon is the lower range, and the upper range being 12.6 miles to the gallon. Now for the dependent matched pairs, we have our lower range as 1 mile to the gallon, and our upper range as 3.8 miles to the gallon. So first of all, and looking at these two different outcomes, what is the range of difference for each of these confidence intervals? So what is the magnitude of difference between the lower and the uppercase value for each of these particular confidence intervals? Well, for our independent, it's going to be 20.4 miles to the gallon. For our dependent, it's 4.8. So, if we're looking at these, this is quite a serious difference in a range of difference, right? In magnitude. So, if we're looking at these, then which confidence interval is going to be the more precise confidence interval? It is going to be the one from the dependent matched pairs. The space is smaller, meaning that when we're looking at that, it is more precise. The range of difference between the scores is smaller. So that is a more precise measurement. Okay, now let's think about this with another thing. So if we have a null hypothesis of mu1 minus mu2 equals 0, and we have a null hypothesis of mu of D equals 0, and that would be the dependent match pairs. So the top one is the independent match pairs, and the bottom one is the null hypothesis presentation for a dependent match pairs. Would you reject or fail to reject the null for each computation? So let's go look at our interpretations for this. So when we're looking at this, we need to ask, does this confidence interval contain the value 0? Because remember, if it contains the value 0, since that is what's proposed by the null, then it is perfectly possible that the null is contained within that confidence interval. So in looking at these, does the independent calculation contain the value 0? And then does the dependent computation contain the value 0? So the independent does contain the value of 0, and the dependent does not. So, looking at this, are we going to reject or fail to reject the null for each of these computations? Well, we're going to fail to reject the null for the independent because the confidence interval does contain the value of 0, so it's fully possible that the null is correct. Looking at the dependent match pairs, we are going to reject the null because here the confidence interval does not contain the value of 0. So when we're looking at these, we get two different interpretations as well. So looking back at these two different types of samples and going, why would we want to use the dependent match pairs? Why wouldn't you always just do the independent independent samples? If we're using the dependent match pairs, when the two pairs do have a meaningful connection between them, we get a more precise assessment, which increases our accuracy. And we get a different interpretation, so we have a stronger confidence in our interpretation. So when we're looking at these, we have more precise, increased accuracy, and a different interpretation for our dependent match pairs, which is why, if it is meaningful and it is relevant with the connection between the two different groups of data, we would prefer to do a dependent match pairs. So I hope this explains for you as we move into this next section, why do we bother to do a dependent match pairs? Why don't we just run independent samples for everything? And this is why we get a more precise assessment here when we have a meaningful connection between our variables, we have an increased accuracy, and we have a different interpretation.